Welcome to Eaton Corporation's series of Launch and Learn presentations. The purpose of this series of presentations is to deliver timely, technical, and application information to you, the electrical consulting engineer or power system designer. Today's presentation is on building information modeling. Today's speaker is David May, Eaton Engineering Automation Manager.
Welcome. Today we're going to talk about building information modeling, or BIM as it's commonly referred to. This is a rapidly expanding trend in the commercial building design industry. Today, nearly half of the architects are using some type of a BIM software tool. Many of Eaton's products are currently available on the Eaton BIM website. I'd like to begin today by defining building information modeling. A BIM project, and when I refer to project, I'm talking about the entire building design and everything contained within it. This project is intended to be a digital relational database of the building design. But it will also contain the information for all the objects contained within the building. And these could consist of anything from walls to windows to electrical equipment. A very powerful component of BIM is that true BIM objects have the ability to share their information with other objects. A good example would be a lighting fixture connected to a breaker in a panel board. BIM is also intended to provide a mechanism for different work groups to collaborate on a design. An example would be architects and mechanical designers working on different elements simultaneously. But ultimately, the holistic view of BIM is to provide the ability to manage the project throughout the life cycle of the building design. We believe having BIM as a facilities management tool would be a very powerful way for Eaton and customers to get access to the information about the equipment. Adoption rates for BIM vary among different user groups, and we'll talk about why that condition exists. For architects, BIM content is the most plentiful. So obviously, there's a big benefit for architects to use BIM because it definitely saves them time designing the project. Contractors who closely follow the architects, and this is primarily large contractors, are also big adopters of BIM because of the savings that they potentially gain in lost time due to errors, for example, in site collisions between building objects. Mechanical, electrical, and plumbing engineers today currently can't find a lot of good content, so they're really late coming to the BIM party, which is one of the reasons it's so important for companies like Eaton to provide content for this type of electrical equipment. And lastly, owners really haven't seen the benefit yet from BIM. Because BIM is new, there are very few facilities management software packages available that can take advantage of the vast amount of data that's included in a BIM software model. Even though BIM has been around for approximately 10 years, most users are relatively new to this BIM technology. So you can see that almost half the users have less than 3 years experience working with BIM. And as we talked about a moment ago, different participants have different value when using BIM. Obviously, architects see the most benefit, followed by structural engineers, and then construction managers and fabricators. But going down the list, you can see very low value today for business owners and product manufacturers. We expect that will change as BIM evolves into some of the other dimensions, which we will discuss a little later. Even though BIM is being adopted across the country, we can see there are certainly stronger areas of BIM usage in certain parts of the country. For example, on the West Coast. There are several drivers for the use of BIM today. One driver would be contractors, who are beginning to mandate the use of BIM as a way to increase revenue. Contractors are realizing more profits through eliminating costly errors that occur in collision or clashes between building objects. Examples could be interferences between plumbing, HVAC, and the electrical equipment. The Corps of Engineers has also written BIM into their specification for all centers of standardization. This is now a requirement for anyone bidding on these projects. Some states are also making BIM a requirement on their projects. For example, Wisconsin and Texas are now mandating that BIM be used on government projects. Now I'd like to spend a little time talking about the BIM models themselves, specifically how BIM object models differ from traditional 3D CAD models. When I'm referring to the BIM models, I'm talking about objects that appear within the project. These could be any type of construction objects, from walls to doors, lights, and electrical equipment. The biggest difference between traditional 3D CAD models and BIM models is BIM models contain data, otherwise known as parameters, and these are things about the product. These parameters are very powerful. They can change the physical size of the model. They can contain web links. They can also contain information about the product, such as the make, the model, and the manufacturer. But arguably, the most significant job of parameters is to establish relationships between objects within the design project. And when I refer to the design project, now I'm talking about the entire building structure design. Examples of relationships could be something as simple as the relationship between a wall and a window, or a light and a breaker and a panel board. Data from building objects may also be used by other objects, and electrical products exhibit excellent examples of this condition. For example, electrical components that have similar voltage are permitted to be placed into an electrical circuit or having an electrical connection with each other, while those items that do not share common voltage are not permitted to be electrically connected to each other. Another very powerful use of parameters is in the production of schedules and bills of material based on the object's parameters. Because objects have this rich parameter data, this data can be used to produce schedules or bills of material based on the parameters on the model itself. Well, let's switch gear and talk a little bit about CAD objects versus intelligent BIM models. Examples of CAD objects could be AutoCAD's .dwg or their translation file, which is a .sat or an A6 format. There's also the neutral step file, which has a file extension of .stp. While the use of these CAD images, and I'm talking about 3D CAD images, does allow visual design. In other words, it allows the user to visualize these 3D objects within the building. These CAD images are considered as merely as graphical objects. In other words, they lack any data. Using these non-intelligent CAD formats may also hinder other features, very powerful features, in the BIM software packages, such as collision detection. There are several dimensions of the building information modeling technology. The first is the most obvious, which is three-dimensional drawings. Most manufacturers can and have been producing 2D drawings for some time. But now the demand, or the first element of BIM, is to produce an accurate three-dimensional model. But unlike what most manufacturers recognize as three-dimensional models, the real intent behind the BIM objects is to rely more on data, or the parameters, and less on the graphics. Adding too much graphic detail causes the object to consume much more memory, which increases the overall size of the building project. So what you would typically see for a BIM object is essentially an outside shell that may not convey everything that a true, rich, graphical 3D object would, but it is very powerful in that it carries all of that parameter data with it. One of the key benefits of the 3D element of BIM is in the form of collision detection. Collisions, or clash detection, occurs when building objects interfere with other building objects. And some really good examples can be found with electrical equipment, plumbing, and HVAC. These elements are typically not modeled or designed in the 2D world. And if they are, it's very difficult without using really good modeling tools to find these interferences. Because the BIM model is spatial, users can run these collision or interference checks between different types of objects.